these problems all deal with subsets or true false, but they also are chosen particularly to illustrate some fine points and things that you need to be careful about. And the way I would think about it is we've gone through this, we've picked up various definitions and little facts that help us along, and I sort of wrote them down on little slips of paper, but these are the kind of things you need to have in your head so that you can bring them out and use them when you need them from your head, from your brain, not necessarily written out on a scrap of paper. So for example, the first problem here says true or false, the empty set is a subset of the set containing the elements A, B, and C. Well, if I have these kind of things in my head that I've been using all along, I will gravitate straight to this little fact, and that is the empty set is a subset of every set and a proper subset of every non-empty set. We're dealing with a regular subset, so this first part of the statement is what we need, and that is that the empty set is a subset of every set. That should be one of the pieces of information that you just have at your disposal. So if someone asks you, is the empty set a subset of something, you can immediately say, yes it is, or that this statement is certainly true. Looking at the second one, it says the empty set is a proper subset of the set containing A, B, and C. Same thing, except it changes from a subset to a proper subset. So what we need is this little fact. The empty set is a proper subset of every non-empty set. Well, the set containing A, B, and C is certainly non-empty, so the empty set would be a proper subset of it. Again, I've drawn from a fact that I know about empty sets and subsets and proper subsets to answer those two questions. And that would be my suggestion to you, to have these facts at your disposal. The third question, the third true or false, says that the empty set is a subset of the empty set. Well, going back here, it says the empty set is a subset of every set. Well, the empty set's a set, so the empty set is a subset of every set, including itself. So that would be true. The fourth one says the empty set is a proper subset of the empty set. Now you can look at this and say, well, the empty set is a proper subset of every non-empty set, and this is a non-empty set. But you could also go back to your definition of a proper subset to get the same confidence that the answer you get here is correct. And that is that the A is a proper subset of B if every element of A is also an element of B, but A and B aren't equal to each other. But the empty set is equal to the empty set. So just the definition of the proper subset itself requires that the two sets not be equal. So this has to be false. So the empty set is a subset of itself, but it's not a proper subset of itself, because no set is a proper subset of itself. Have those little facts at your disposal, and you can draw on them when you need them. Moving along to the fifth problem, it says list all the two-element subsets of the set containing 1, 2, and 3. This doesn't really require any of the definitions of facts, but you do need to know that you're trying to pull every combination of two elements. So you could take 1 with 2, that would be a two-element set. You could take 1 with 3, that would be another two-element set. And you could take 2 with 3. And I claim there aren't any more combinations of two-element sets, because remember, order doesn't matter, so 3, 2 is not a different set. And last, the sixth one says how many subsets does the set containing A, E, I, O, U have? Again, it requires pulling from your knowledge base this little fact. A set with n elements has 2 to the n subsets. This set has 5 elements, so that means that there are 2 to the 5th That's 2 times 2 times 2 times 2 times 2, which is 32 subsets. So that's any set with 5 elements has 32 subsets. So you can see you're pulling from the information, the facts, the definitions that you have already in your head, and you're applying them where you need to. But you do have to have that base of knowledge to pull from. And if you do, the problems really are very easy.